Hello, everybody.
Hello, hello. Thank you, everybody, for coming out. I know it was a late night last night for some of us, so appreciate it. I'm Dorian V, co-founder, CTO of Imerza, and my clicker's not working. There we go.
Oh, there it goes. And I'm Tom. I'm the Vice President of Technology at Imerza.
Imerza is a tech company that evolved out of an architecture firm. Tom and I began working in real-time engines many, many years ago, back in UDK days. But in the architecture firm, we dove in headfirst in the early 2010s, I think, and have been working with Unreal since then, developing tech on top of the engine to help in the design projects in the AEC space. And Imerza evolved out of that architecture firm, and we work on digital twins and real estate marketing, as well as immersive sales galleries. A handful of projects. In the top left, there's a sales app for Lend-Lease. Top middle is a estimating app we did for Walgreens. On the right is a countrywide digital twin we worked on with Bentley Systems. And we also work on really, really big design digital twins, such as some of the work we're doing in Saudi, which our talk was on last year. And then the last image there is a pretty cool experiential sales center with some projection mapping that we did for the Edition residences, Edgewater. Imerza has been around since 2017, and we've been quite fortunate. We've done hundreds of projects all over the world with some of the top real estate developers, and it's been a really interesting journey. We've seen the adoption of tech really skyrocket in the last couple of years. Clients are asking for real time now, where previously it was something they had never heard of. The project we're talking about today, we did for CBRE. If you don't know who CBRE is, they are the world's largest real estate services brokerage. They have somewhere in the neighborhood of 150,000 employees, 500 offices globally, and they have more real estate data than anybody on the planet. So the project we're talking about today is really two big ideas. One is their internal product called CBRE Market Canvas, and the other is a metamorphic experience center. So what is Market Canvas? Market Canvas is a global data platform and digital twin for market analysis. This is what all of their brokers are going to be using to query a property, a range of properties, access that massive wealth of data that CBRE has, and show these properties. And the Experience Center, this was one we did 5 years ago now, 6 years ago. This was a pretty special experience center. In this project, what we did, we had a 3D printed 17-foot diameter scale model that we projection mapped, everything coming from Unreal, tied to live data, all sorts of cool stuff in there. They could show monthly rent growth, they could show demographics, they could show the view from every floor of every building. And as far as real estate marketing centers go, this one is pretty tough to beat. It's still the most effective and impressive sales center I've seen to date. So how do we top that? Well, some genius, I don't know who thought of this, had the idea of, well, what if we could change the shape of that table too? Really dumb idea. I don't regret thinking of that one at all. Actually, it wasn't my idea technically. Somebody else had thought of it in the past. Only this is completely fake. And we wanted to make it real.
But this was certainly the inspiration. But they had the benefit of not having to deal with actual physics.
Yep.
I'm a little jealous.
Yeah, which Tom just pointed out. I didn't catch it earlier. But you can see that the bridge is floating. Look at that. How are they doing that? So all the puzzle pieces for the project and the partners involved. Of course, you can't do a project like this without an amazing client. CBRE has been an amazing client. They took a massive risk in starting down this journey with us. You've got us, our partner on the hardware installation side, DC Volts, Rare Volume on the design side, Coalition on the back end, SUSTech, Research University out of Shenzhen, and then Cesium, Vexel, LightAct, and Eagle 3D. So Market Canvas actually has two really major components that were equally difficult to figure out. So there's, of course, the visual component of this, digital twin, which is the globe and every property available to sell in the globe. And how do you make a scalable platform that clients can manage themselves, update with new building data, and combine that with custom photogrammetry and BIM data? And normally we would revert to our typical tricks of Datasmith and Nanite and making things look fantastic. But in this case, it had to be streamed 100%. This is a platform, so we collaborated with Cesium and came up with a fantastic method to blend all of these data types, including what they just released access to a SDK for BIM data tiling, which is very much worth checking out. And all of that pulls together into a super high resolution photogrammetry model of the globe. And go to the next one here. And then the next piece of it is the data. So there's tons of real estate data they have that they want to visualize, all different types of data, everything from rent to availability to mobility to demographics. And they want to do this all in real time. They completely modernized their data stack and are running everything off of a massive data lake that we are connecting to through SQL. And when they were prototyping with a product called Cardo using DeckGL, which DeckGL is a fantastic viz library for WebGL. And we learned a lot from DeckGL, actually. And the only issue is you can't get the sexiness that you can get at Unreal. And they really wanted this to be the sexiest real estate platform anybody's ever seen. So we had to essentially write our own version of DeckGL in Unreal.
And unfortunately, we looked high and low, and there is not an integration already. I'll expand on what Dorian said about DeckGL. It's a great library of visualization objects that you can kind of connect to a GeoJSON string and build polygons and put points. And you saw maybe some of those H3 tiles on there. So we were like, oh, great, we'll just bring this into Unreal and it'll be great. Unfortunately, none of that was there. So yeah, we had to kind of start from scratch. So we had the goals of it had to be asynchronous. It had to always run. We couldn't have someone waiting minutes or even seconds for things to happen. If they were waiting, it should stay live. We lean on lots of libraries already that are out there. Epic just announced the GDAL library. We brought in the H3 library, a bunch of GeoJSON libraries, and we brought them into a C++ plugin. There's lots available, so that was nice. We didn't have to engineer all of that from scratch, but what we did have to figure out is how to get Unreal to talk to a database and process huge amounts of data asynchronously, and do it both at runtime and in the editor, which, if you've ever played with connecting to data sources in Unreal, those two environments act very, very differently, and we had different purposes. Sometimes we'd want to bring data in and record it statically in the editor, or we'd need it to run at runtime to be able to be immutable. What we ended up with is kind of taking a look at how DecGL worked, and DecGL basically has layers you can build up. You say, I want a terrain layer and a map layer and some geometry layers, and they're all defined with kind of a JSON sort of format. And so we took a look at that and we're like, that's a great idea. So we built the system to use externally defined style sheets. The other nice thing is that we can deploy the application, and when they want to change the colors or the thickness of a line, they just change something in the HTML page, and we don't have to redeliver the application.
Because marketing departments never change colors. Yeah,
that would never happen. And of course, as we went on, we had to add lots and lots of options to these. Some examples of where we ended up with this. So we connect to a database, we pull in GeoJSON data, and then we have processes that will process that data into data formats that Unreal really likes. For example, geometry script. So we get back a whole bunch of strings with lat longs in them, and we pass them through a bunch of asynchronously written C++ nodes that convert them to something like a vertex array list, position list, which is a data format that Unreal really likes, and so we can feed that into that system, and it works really quickly. We can also control all of the look and feel of materials and post-process. All of that can be defined through those style sheets. And so they can get kind of varied looks from it, all with just a couple of commands. And then this is an example of that H3 data set. So this is kind of a custom kind of data set that we had never worked with before.
It was written by Uber.
Yeah, it's written by Uber. When you order an Uber, it actually breaks down the world into these hexagons, and that's how it knows where to send your Uber. It's actually not sending it to a lat long or anything like that. It's this system. So yeah, it splits the world into a bunch of hexagons, and then splits those into hexagons and further. And what we managed to do is use Cardo to collate that data and feed that into H3. And so each one of these cells looks at the amount of data in that area and then returns that. And then we feed that. I think in this case, this is going to...
This is combining H3 data with the boundaries. And so we're able to like trim all of that in Unreal.
Right. And here's a very advanced example where we're taking the outline of a building, and then we're also getting the number of floors that are in the building, and then sampling from cesium, the top and bottom, and then taking that data. So all of this gets returned from a single SQL query, and the system can parse that. We also can do points in huge areas. And because we're leaning into Unreal's native systems, it runs really, really well. So we can render thousands and thousands of points without a performance penalty. So we kind of were worried about.
And generate thousands and thousands of buildings and polygons, in milliseconds, less than milliseconds in some cases.
Sometimes many, many minutes, though, which is sometimes the database takes a long time. Sometimes the database is just returning so many points that it just takes a while for Unreal to build everything. But by and large, everything, as you can see, ended up being very, very quick.
Yep, and fortunately, the caching system, if somebody ran that query where there's showing maybe 10,000 different buildings for whatever reason, and those were really only the scenarios that it would take those minutes instead. It caches all of that data, so the next time you run it, it's milliseconds. So how this all pulls together in the web. So we decided to go with pixel streaming because the client did not want to have anything that looked close to WebGL graphics or standard Carto maps. And they're able to pick any district in the world, any sub-district in the world, drill down to any building and access all of that deep data that the CBRE has on properties, everything from, I think I mentioned it, from leasing to availability to, they've got AI models running in there to show where things are heading with rents and occupancy and absorption and things like that. And start making some really cool looking data viz. And then how do you experience it? So they can pull all of this up, select it, fly into any property. This is DC, which was where we were prototyping. Find a building with nice high-res BIM data, select a floor, and then jump right into that unit. I didn't mention it, but CBRE is actually really forward-thinking, especially in real time. They acquired a company called Floored back in 2008, I think, 2007, which was one of the first real-time rendered real estate marketing pieces of software out there. And this is an evolution of that for sure. So that product you could only do interiors in, and Market Canvas. You can show the full building, all of its plazas in high detail, and then jump right into it. So the Experience Center. So how are we going to pull this thing off? So this is the physical extension of Market Canvas, and is a presentation space, of course. And you click to the next one. Where we landed is not quite as dense of a table as the X-Men one. This isn't a $100 million project, but we'll get those costs down soon.
Yeah.
Where we landed is roughly around 5,000 pins that are linear actuators that are getting driven from Unreal Engine, and we're then projecting onto that table. Yeah, so dynamic projection surface. Why not? Yeah, let's just do this. So this table is broken into modules essentially, blocks of 10, because this thing has to be serviceable. It has to operate long hours, and if a pin breaks or a module breaks, somebody has to be able to get in there and replace it quickly. So we designed this really modular system with DC Bolt and SUSTech to be able to plug these blocks in, have the whole thing running. Everything's custom engineered, literally everything in it, from the motors to the PCBs to the pins themselves. Tried using off-the-shelf stuff for cost reasons, but it just didn't work. and even down to some of the cooling. When you've got 5,000 electric motors running next to each other, things get a little warm, much warmer than my backpack with my laptop in it. But we had to figure out, how to get the air out of there, and not suck the hot air then back into it immediately, because this is and it's a table where this is all kind of buried in the base of the table. And after about a year of engineering and back and forth, amazingly, the thing works. This was the first prototype block this was a global team that's working on it. The team from SUSTech, they came over. Team from LIDAC, they came over. This was just last month, and installed the prototype block working. And then I turned to Tom and said, "Hey, Tom, we got to make this thing work in Unreal." And he didn't resign. So
no, this is why I came to Imerza, was to do this kind of thing. This like, all right, we need to control a piece of hardware that isn't actually made yet. How? And so I was like, well, I think I know how. And so I started experimenting. And the first experiments actually went really well. This is actually one of the first, this is like day one, where I was like, I'm going to make it work. Because as soon as he said, make the X-Men pin table, I was like, I'm on it. Let's go. So my first port of call was Niagara. Because the original design was 100 by 100, and I was like, whoa, 10,000 actors moving around. There's only one way I'm going to deal with this. And so I think that this might be 100 by 100 in this. But yeah, built-in Niagara, and this is very simple. I just took it's a single height map, texture map, scene capture. That's where you can see wait, my laser, haha. So that's what I'm moving around there, is just a scene capture, and it's being fed into a Niagara system that's sampling that, and right now doing really bad math to figure out the height. I hadn't done any actual engineering. It was like, will it actually work? I also added in a bunch of like variation and things that, of course, the client was like, can you please remove all of those? And then, as you saw, the actual pin table had them. But
because the interesting thing here is we're sampling the Unreal environment to then generate this pin table, but the Unreal pin table needs to perfectly match the physical pin table. Otherwise, because it's projection mapping, there would be light leaks and everything. So we're sampling it out, going out, and then sampling that to bring it back in.
Oh, let's talk about that. So as you saw, we got the height, and then I started to get some color in there, but that was really very low res. It was like each pin was being sampled with the color of the texture. Obviously not enough. So we're looking at it, and it's like, well, I think the only way that we can manage this is we have to capture it from all sides. We can't do it with a cube in the middle, because there'll be too much occlusion.
You can't actually do it from the side. You have to do it from the side and the angle and the angle.
and there'll still be, chances where pins will occlude others. But what we came up with is, the four Cartesian and a top down. So 5, but actually 6, because we need to sample the height maps separate from the visuals that we're sampling. Luckily, Unreal Engine, or just as we were starting this, I think it was 5.3. 5.3 came out, one of the big features was orthographic rendering, which if we didn't have that working like it does, this would have required so much more math, and I would have resigned. There's a limit to how much math I'll do in a day. And so because everything was orthographic projected, as you can see, we could have 4 samplers, and then we had a genius on our team I was like, can you please figure out a material that will reproject these? And he came back like an hour later and was like, no, I use decals, because decals orthographically project. And I was like, well, there you go. That took less time than I was thinking. And that's really how the system works. So we're capturing the cesium world and then reprojecting that onto a simulation. And then we're capturing the simulation.
Again.
So there are 12 scene captures running in one instance. On a 4090, this works at like 40 frames a second. On my laptop, about 15. So it's very, especially GPU RAM intensive. Like I'm right over my 8 gigabytes immediately. Not to be surprised. But if you've got the VRAM, it worked really well. We're capturing full lumen, we got shadows, and it worked really well.
Yeah, and the scene or the project is incredibly light because everything was dynamic, getting driven by data. I think you could see in the previous slide there was 75 actors in the scene, and that gives us everything we need for the entire planet and everything that we're doing in it. And yeah, the system here accurately projects everything onto the sides of the pins, just where it's supposed to be, and yeah, it's really fun to play with, by the way.
You spend way too much time just like moving pins around and making fun stuff happen. Moving the light around, this is one of my favorite things, was we weren't quite sure that the projection mapping would read right. It's one of those questions you don't know until it's actually fully working, and then we were like, whew, it does, it looks good. But we realized that like the artists, people were having a hard time setting up scenes because they don't have a pin table next to them. So I went and did a bunch of tech artwork, which is what I love to do, to figure out how to communicate, like, what is the height of the table? What are its dimensions? I had to do a lot of math to get this to work. But in the end, you can see exactly where the pins will actually be, because that's the actual simulation that's been, again, reprojected. And then nice colors to help you understand like when the pins are at their full extension or not extended at all.
Yeah, because different regions have different height buildings, and yeah, we got to be able to figure out what's when something's coming in and generating that dynamically. Yeah, is it going to be a squashed building or yeah?
And of course, none of the buildings that they actually wanted to see looked anything like the concept buildings they gave us at the beginning. Totally different scales, style, everything. So got to go and make it very flexible. But I just wanted to show how actually decent the projection ended up working. So the table here is actually unlit, and the lighting is lighting another scene somewhere else, and that's the reprojection. We can also do stylized combinations of things, and we're just really, really stoked that even when the pins can't really match the visuals because their resolution is too low, the projection fills that in really well, and your eyes kind of fill in the gaps for you. So then we were like, okay, we've got a Niagara system that's simulating this thing. Well, how do we actually tell all of these other systems how high these pins are? And that was, again, stupidly simple because Unreal's got a thing for it already built in. So if you don't know about this is one of my favorite things, the export particle data from Blueprint right here. This just every frame, once you get it set up with this little setup here, but every frame it calls this, which sends this data out every frame. And we're sending 4,900 instances, and it doesn't even show up on the profiler. This is free. So you can get all of that data. I did a big test with like bullets, trying to see how many bullets could I send and have it send collision responses. And there were tens of thousands, and it was like, I'm fine, I'm good. Blueprint spent more time iterating through the loop than it did sending the data. And so, yeah, we're sending all of that data from this particle system to all of these systems. So the heart of this entire enterprise is a single Niagara particle system that's actually not a whole lot of stuff. Luckily, there's a lot of other complexities that we had to deal with. So it was nice that the Unreal side was pretty straightforward.
Oh, yeah. So then we then have to get that shape, dynamic shape on the fly to the projection mapping software. And this is the LIDAC team when we were there last month. So what we're doing through what Tom just described, we're actually sending all of that pin information, the pin heights, we're at like 0.5 millimeter accuracy, over to LIDAC, which they are then recreating that for the projection mesh again in LIDAC. So we're sending that through JSON, and everything is then set up to be able to project on it. And amazingly, we're getting 0 light leaks. Like the thing works perfectly. This was the prototype block that we installed last month, and yeah, it's definitely a success.
And this was, it's one of those things where you work for a year, everyone off in their own part of the world, and you get 1 week where everyone flies in to get this thing to come together, and you don't really know until you know. And there were, of course, all kinds of fun little things like, they installed the table 90 degrees this way, which made us all freak out for 10 seconds.
Oh, yes.
Maybe more than 10 seconds.
Yeah, actually, I'll back up a couple slides there. So that was a really fun thing to figure out when the team working on the PCBs and the hardware controllers, not only was their orientation different than ours, they had reversed one of the axes on top of that. And then the team that installed this prototype installed it, rotated 90 degrees. So yeah, on this day, you've got 6 to 8 engineers all beating their heads against the wall, going, why is it backwards?
Right.
It should not be backwards.
And then, of course, everyone's like trying to do math, and then I'm like, wait, what if we just rotate the actor? And yeah, that was it. That was it. Just rotate it like they did. Oh, there you go.
Yeah, because it was then getting compounded because every system that was doing it had to do this exact same thing. So yeah, that was definitely a fun one. But in the end, it all came together and is working pretty seamlessly. And yeah, and now we are in full-blown manufacturing. We've got another month and a half, I think, of that. Again, like I'd mentioned, literally everything is custom motors, custom PCBs, custom screws, custom everything. And we found a really great fabrication partner in Shenzhen that actually had a couple of the pieces in there all under one roof, from the injection molding to the machine work. And the full table will be installed in another month and a half, approximately. And Santa's going to be bringing us a big moving metamorphic table for Christmas.
Well, thank you all for coming, and especially so late in the fest. If you've got any other questions, please reach out to us on LinkedIn, or come find us after the show, and we're happy to talk.
Thanks.
Thank you.